Welcome to another episode about digital identity and trust in the age of AI and intelligent agents. If this is the first time we meet, I recommend watching Why AI Agents Need Identities. It sets the stage by explaining the identity vacuum in digital space and how the internet has been filling that void with credentials, an access control mechanism that's the mirror opposite of identity, both in nature and effect. In that video, I talk about how credentials interfere with trust, shape cybersecurity, and why that becomes a problem as AI takes on a more agentic role. Today I'll be talking about uniqueness, the core tenet behind the first principle of agentic identity. I'll explore how uniqueness affects the dynamics of interaction, the hidden cost of relying on credentials to control access in digital space, and what that means for an agentic future. Let's go back for a moment to the PO Box model and recall that there are two ways to access the content of the PO Box. Authentication, which validates that you hold the right key to the right box in the right post office, and identification, when an officer checks your ID and the register to see which box you are allowed to access. For either of these methods to fulfill their purpose, the artifact based on which the access is decided must be unique, mutually exclusive. Otherwise, two distinct but indistinguishable artifacts could unlock access, and that would negate the control part in access control. In case of identification, that artifact is yourself, the agent, being matched against information stored at the post office. In case of authentication, it's the credential you hold being matched against information about the point of service. In both cases, we have exactly one unique artifact being used to determine access control, applied in a manner that would appear to be symmetrical. In case of identification, the post office holds information about the real you, and in case of authentication, you hold information about the real PO Box. What's remarkable is that although this symmetry is real, it exists in an asymmetrical environment. The nature of interaction is such that the artifact of authentication is always with the agent of action, and the access control is always done by the point of service. This seemingly insignificant polarity, which looks more like a wordplay than a real thing, makes authentication dramatically more difficult than identification. The reason is topology, the nature of space in which phenomena reside, and it's a bit like entropy in physics. Our laws of physics are symmetrical in spacetime. In theory, chemical and physical reactions should be reversible just as you can undo a step by walking in the opposite direction. And yet, because time is asymmetrical, it always flows in one direction. This is not what we observe. Doing things with the arrow of time, increasing entropy, is far easier than doing them against it. That is why it's easy to break an egg, but practically impossible to put it back together. This may seem like an unfair comparison for identification versus authentication, but it is in fact grounded in the mathematics behind the model. Here's why. Whether it's authentication or identification, the service provider, the post office in our case, has to perform some maintenance job per each relationship aside from the access control process itself. If it's identification, it needs to maintain a list of relationships with respect to which agent has access to which box. And if it's authentication, then it needs to manage the credentials for the agent renting the box. For example, change the lock and the key if the agent lost the key. If the post office has n client relationships, that means that the service provider side of things introduces a factor of n to the relationship complexity formula. Due to the asymmetry imposed by the interaction, the same logic does not apply for the agent. In case of identification, when access control is determined based on the identity of the agent will use its unique identity with each relationship it has, regardless of the number of services it interacts with. There is nothing to manage, ever, other than the single identity it possesses. As a result, identification introduces a factor of 1 into the complexity formula. With authentication, on the other hand, beside its own identity, the agent must maintain a set of credentials for each point of service it accesses. It needs to make sure to carry the credentials to the point of service, otherwise there is no business. It needs to keep them safe from anybody when not in use and take immediate action if a key is lost, even if it's just misplaced in the house. Basically, an entire process individually for each and every service. For an agent that consumes m services, authentication introduces a factor of m into the complexity function. If you're quick to notice that the 1 representing the identity maintenance in the formula is practically insignificant, you'd be absolutely right. This shows the monumental difference in terms of effort, which is the direct result of complexity between identification and authentication as imposed by the asymmetric nature of interaction. Identification effort is linear because it works with the arrow of interaction, and authentication effort is geometric because it goes against it. This is huge, and yet this is simply the raw theoretical model difference. In practice, the difference is much bigger due to further asymmetries in operational friction. In case of identification, the artifact of access control process is the identity, the unchanging thing that follows agents everywhere at no effort. That said, people do have to occasionally update their IDs, which is why the complexity of identity is 1 as opposed to 0. IDs have a fixed time validity. They may get damaged, lost, or people may change their names for various reasons, like marriage. This maintenance is somewhat inconvenient, but generally not that big of a deal, in the sense that people don't really need active management or tools around this process. The overall effort of identity management on the agent side is very small, sporadic as opposed to operational. Furthermore, when IDs change, only the IDs do, the identity itself does not, resulting in very little impact at the point of business. Even when services require agent IDs as proof of identity, most interaction in the real world does not, updating reference data can be performed seamlessly at the next time of visit. Even though this maintenance task exists individually for all end-client relationships, it's also sporadic and non-disruptive. The complexity of identification is a non-penalizing complexity. I will call it a soft complexity because there is no interdependency, nor is there any urgency in relation to the update process. Nothing breaks if things are not actively maintained. Identification is favorably aligned with the asymmetry imposed by interaction. As a result, it feels as simple and as natural as breaking an egg. The same is not true for authentication. Here, the service provider cannot unilaterally change the access credentials, otherwise the service consumer agent loses access to the service it pays for. Nor can the agent unilaterally change the credentials, as the process of changing the lock is owned by the service provider. Any modification brought to the access credential can only be performed in tandem, not only together, but synchronously together. Because of the interaction asymmetry, credentials end up having a co-owned nature, meaning that any phenomenon surrounding them is only complete or consistent when owners are synchronized. This is not only true for the management of credentials, but also for visibility and control. The service provider, for instance, has no way to know if the agent loses the key to the box or gives it to someone else to access it. Equally true, the user has no way of knowing if the service provider accidentally gives a copy to someone else. To overcome this naturally unfavorable alignment with the polarity of interaction, authentication needs to continually input effort just to stay in one place. The nature of credentials is such that they are inconsistent whenever the independent parties co-owning them are not fully in sync, which is almost all the time. As a result, not only do peers need to invest active effort to synchronize whenever an imbalance is created on their side, but they should also continually probe the status of the credentials with peers to minimize that window of inconsistency. In other words, they are required to work all the time, even when credentials are not being used. The complexity of authentication is permanent and has interdependencies. I will call this a hard complexity because it does not naturally fit into the flow of relationship and interaction. Instead, it needs tools and continuous effort to be kept consistent. Service providers need dedicated management, monitoring, and response tools and processes permanently ready to engage with any of their end customers. This is also true for agents, who should employ an equally sophisticated stack of tools and processes to stay engaged with any of the end services they have a relation with. Even so, the unforgiving reality is that a state of full consistency can never be reached, no matter how much effort peers invest, which is why cybersecurity feels like working on putting the egg back together. This dichotomy can be surprisingly intuitive if we look at it from the perspective of ownership and control. With identification, the owner of the identity has continuous exclusive control over the artifact of access. Therefore, sporadic maintenance is sufficient to keep the identity consistent. Conversely, with authentication, parties only have sporadic control over the artifact of access. Therefore, they must continuously work to ascertain and maintain consistency. The choice of deciding access based on information about the point of business, as opposed to information about the agent of action, is not only against the arrow of social interaction, it is also incomplete from a social dynamics perspective. An important practical problem entities need to solve is to share access to resources. This is almost never a uniform access. It depends instead on social relationships, positions, status, which we can collectively call roles. In real life, roles are powerful instruments that enable fine-grained segmentation of access to resources. Not only do I know who has access to a resource, but I can also personalize access, tailor access to the individual. This is possible because with identification, I am pairing roles with identity, meaning that during identification, I can ascertain both the actor and the role, everything needed for personalization. The fact that I am giving access to the same resource to multiple individuals, for example, the same bank account to pick something more elaborate than a PO box, has no detrimental effect with respect to my ability to personalize access. Sorry for sounding like a broken record, but again, the opposite is true for credentials. Since credentials describe the point of business, the bank account, all I can pair the role with is the key. Each type of key describes a certain type of access. The problem at hand, however, requires that I give copies of the same key to multiple individuals that share the same role. Instead of personalization, I now have generalization. For a practical example, consider a simple application stack with a database at the center and 10 application parts, let's call them microservices, that serve different functions as part of the entire application stack. Since all microservices ultimately serve the same common goal, most of them will need to access the same database where all business data is stored. The general approach is to create a series of database credentials for role-based privilege segmentation and then use those credentials across the microservices based on how and what they need to access. There's a logic behind being frugal on the number of credentials when segmenting privilege this way. Normally, microservices access each other also using credentials, so even in a modest environment, the complexity of credentials is significant. It is estimated that in digital space, the number of service credentials, often improperly called non-human identities, have reached a ratio of 50:1 with credentials used by humans. This is not surprising considering the M by N nature of credential-oriented relationship management, but this type of frugality has a very dark side. Typically, a credential is used in 10 to 50 distinct places in an application stack, owing to the fact that different parts of the overall service need to access the same business endpoint at various steps. Even if our example was to be a moderately sized production environment where each microservice distributes workload over 5 worker machines, we will have anywhere between 50 to 250 live instances where the credential is actively in use as part of the customer serving production. This effectively introduces a replication parameter R to the complexity function of authentication, which takes us back to the problem of uniqueness, the basis of any meaningful access control. Credentials may describe unique points of business, but they are in fact not unique. In any given deployment, there are between R and R by M copies of each credential deployed at various generic points of usage, for the lack of a better terminology, making it impossible to understand the origin of requests. Notice how, looking at credentials from the perspective of the database, it is impossible to pinpoint the source of request. They come from nowhere and everywhere. There is no way to draw a box around the thing that makes the request based on credential alone. Credentials are fundamentally anti-agent. They don't individualize, they generalize. In practical terms, generalization is an information obfuscator, which hits both from an operational perspective, but more importantly, from a control perspective. Instead of more information and more control with no impact on complexity, as is the case of personalization, combining roles with credentials leads to less information, less control, and a massive penalty on complexity. To change a single credential, the service provider, owner of the credential, needs to synchronize with the service consumer, custodian of the credential, who needs to synchronously update the credential on all instances at all points of usage, both live and dormant. Above a certain scale, this is impossible to get right, and when it fails, there is no way to tell where it failed. This is why, even with advanced IAM solutions, secrets management, or privileged access tools, organizations often feel like they're running uphill, expending enormous effort just to hold the line. The inherent tendency to break the chain of trust, which I've articulated in the last video, and the asymmetry which manifests as systemic lack of consistency and control, coupled with an impractically large complexity, make the credential-oriented architecture the weakest link in cybersecurity, not people. Undoubtedly, people are not perfect, but this is normal. It is true for every industry, and yet the aviation industry, which is still heavily reliant on humans for operations, is one of the safest industries in existence. Flying is astronomically safer than operating in digital space because the technology is aligned to compensate for human weaknesses, not amplify them. The transition from human actors to AI actors is not only amplifying the number of credentials, but it's also creating a management vacuum. It disempowers real-world entities on the service consumer side by taking control away from them. After all, the whole point of agency is autonomy, which is the opposite of control. To make access control work for agents, we need an architecture where less control is sufficient and agents can retain ownership of the means of access. We need identity. In nature, we are bound by entropy. We cannot uncrack an egg any more than we can go back in time. This is because we cannot change the nature of the spacetime in which we exist. But in digital space, we can choose the structure of interaction. Let me know what you think in the comments below and subscribe to get notified. In my next video, I'll be introducing the concept of an identity-oriented architecture, a more natural dynamic that aligns the access control process with the arrow of social interaction. I will also be looking at practical examples of how this transforms visibility, control, and the complexity of an interacting environment, as well as some strategic steps anyone can take to softly transition from a credential-oriented architecture to an identity-oriented architecture without business disruption. Thank you for your time.